Now it gives me great pleasure to invite Mark Disendorf to speak to us. Mark was a principal scientist at the CSIRO in renewable energy. He's a founder of several renewable energy initiatives, including, I think, Wind Energy Australia. He's now working at the Institute of Environmental Studies at the University of New South Wales, and the author of 2 recent books, Greenhouse Solutions and Climate Action. So over to Mark. Thank you.
Well, thanks very much, Lindsay, and ladies and gentlemen, thanks for coming on a Saturday afternoon. Well, I'm wearing my hat this afternoon from the Institute of Environmental Studies at University of New South Wales, and I've been asked to talk about renewable energy.
Okay.
But first, I just want to put it into a broader context. There's really 3 principal drivers of environmental impact, and in particular greenhouse pollution. They're the technologies, dirty technologies like coal-fired power stations, energy wastage that John Judson was talking about. We can include forestry practices and agricultural practices under technologies in a broad sense. There's the growth in consumption per person, which keeps making the wheels of industry and the wheels of vehicles turn faster and faster. And there's the growth in population. And I believe that we have to address all 3 of those if we're to be effective in creating a sustainable society and a sustainable environment. But I'll focus on energy and renewable energy in particular. So I can start with good news because there's also bad news, as you've probably anticipated. Well, the good news is that, as other speakers have said, we really have the technologies now for creating a sustainable Australia in terms of energy. And energy is the driving force of our economy. If we can do it with energy, then everything else can follow, more or less. And it involves a combination of using energy more efficiently, that John Judson was talking about, and making a shift, making a transition to renewable sources of energy. So, I guess the light's running in, but if you can see that on the top left, bioenergy, burning sugarcane residues, not native forests. In Queensland, top right, wind power, bottom left, solar efficient homes in a cooperative housing development in Adelaide called Christie Walk, and various solar systems. Now, we can't run the Australian energy system on any single one of those at present. But what we can do now, that all these technologies have advanced to a sufficient stage where if we take them all together, we can create an energy system that is just as reliable as the existing dirty system, only much cleaner, and creating far more local jobs within Australia than the existing system. So together we can do it. And I just want to underline one of the slides that John showed. You remember he showed a graph where you had a lot of bars going down, which were energy efficiency, and they were going down because they actually save money. And then you had on the right-hand side a number of bars going up, which were energy supply, which were costing more than 0. And if you look at that graph, you can see that a large part, that the economic savings from energy efficiency are so large that they could actually pay a large part of the costs going up of the cleaner energy supply technologies. So that gives us a lot of hope. And it also means that making the transition, if we do it in a smart way, is going to be a lot less expensive than any other scenario. Okay, so now I'll just go through very quickly through some energy supply technologies. Some of them will be very familiar to you, and I'm starting with those that are most cost effective. And I have to put solar hot water as one of those. Yes, it has a higher upfront cost, but over its lifetime it pays off that upfront cost, and it's certainly cost effective now. And in greenhouse terms, the best combination is solar hot water boosted by instantaneous gas, although that is more expensive than the solar electric combination. Now, just to give you an idea of the savings that could be made in Australia, currently in the sunny country, solar hot water is between 6 and 7% of hot water systems in the country. It's absolutely ridiculous. At the same time, what appears to be a totally unconnected fact is that between midnight and dawn, a number of coal-fired power stations are doing nothing but burning away heating hot water between midnight and dawn and producing quite significant greenhouse gas emissions. Now, according to my calculations, we could close down in Australia 4,600 megawatts of coal-fired power. That's a lot. That's equivalent to 4 standard-size coal-fired power stations, or 2 gigantic size, equivalent to the 2 that are being pushed in New South Wales right now, simply by shifting away from heating water electrically during the night, just to keep those coal-fired power stations burning, and shifting over to solar hot water, and for those who don't have sunshine on their roofs, instantaneous gas hot water. So in one fell swoop, in New South Wales, we could eliminate the alleged need for 1 new gigantic coal-fired power station. And in a second swoop, by implementing energy efficiency seriously, we could knock out the other one and more. So when you hear politicians say, well, we've got to have these new coal-fired power stations, it ain't true. They're simply not looking at the alternatives that are in front of them. And perhaps they don't want to because, say, in New South Wales, the state government takes the profits from electricity generation, so it's not in the government's interest to reduce electricity generation through energy efficiency and solar hot water. Wind power is a mainstream technology now overseas. Last year in Europe, wind power provided the biggest contribution to new generating capacity in Europe by far. And in 2008, it did the same thing. So this is an industry worth tens of billions of dollars a year. It is a mainstream industry. It's still fairly small in Australia due to the lack of appropriate government policies we'll come into. Global capacity, for those who like numbers, last year reached 159,000 megawatts. Well, to give you an idea, Australia's generating capacity is about 46,000 megawatts. And it's growing at about 25 to 30% per year. So this is a big industry. It could be providing 20% of our electricity within a decade, given the right policies, and probably 25 or 30% by 2030. And that includes ensuring that the fluctuations in wind power are smoothed out. To do that, however, we would need to make some improvements in the existing transmission system, which was originally built and paid for by electricity consumers. The current situation now is that if you want to connect a wind farm to the grid, the developer, if you're the developer, has to pay the transmission connection to the grid. That wasn't the case for coal-fired power stations in the past. Now, what we really need right now, I mean now, not in 10 years' time, is a new transmission line from South Australia to connect with the main grid in New South Wales in the east, to bring some of the huge wind power potential in South Australia that still hasn't been tapped. Currently, there is enough wind power in South Australia to meet that state's demands, and there won't be any significant further development until there are enhanced connections to the eastern states.